that was fun.
Hello, and welcome everyone to the 11th episode of Inside AMG, where we have arrived at the letter K. Now that is going to be K as in kinematics. Very complex, very technical topic, but also a very interesting one because we're going to be taking a look at kinematics from the perspective of our very own AMG driving simulator. And of course, as usual, we're also going to be having a number of experts. The first one of those experts is going to be AMG's godfather of kinematics, Michael.
Hi Felix, how are you doing?
Very well indeed, thank you.
What are you doing with my simulator cabin there?
I was taking it for a little spin, but I gotta say it lacks a bit of engine power.
Yeah, that's true, but we're going to give you some more later on.
Awesome.
Come on in, I've got something prepared for you.
Perfect, thanks. Oh, wow.
So there it is.
Not bad, not bad.
We're very lucky that we got the model here right now. So
absolutely, I mean, I do recognize this.
Yes.
This is very, very special stuff, very motorsporty. Yeah, what can you tell us about the configuration here?
Yeah, kinematics are actually about two main things. Keep the tire happy and keep the driver happy. Concerning the tire, we coordinate how the wheel is moving over bumps, how it is moving forward and backwards, and most importantly, how the camber and toe angles react. So camber is how the tire is leaning inside, toe are steering angles. So camber is important because we are leaning outside while cornering, and therefore we need to lean the tire inside to have an even tire pressure distribution, that is to get the main out of the grip.
So basically, when we're talking about kinematics, we're always focusing on this part right here, so to speak, everything that happens between the wheel and the rest of the suspension
and the body.
Configuration.
Right, exactly.
So everything comes together basically because it's the whole connection between wheel and chassis. Everything the driver feels when driving the car is translated through all these different parts that we see here. I mean, this already looks highly complex. Is this? I mean, this is a very special car we're standing in front of.
That's a special configuration here. Yeah.
Is that representative of any road car?
Well, the spring dampers inside here is a push rod and a roll heave damper system that is not on the normal car. That is very motorsport orientated. You see that in DTM or Formula 1 cars, a little bit smaller, but that's what you see when they get off the hood. But the rest of it here, it's a very special 5-link configuration. Normally on sporty cars you have quite often a double wishbone suspension, but we decided to have a 5-link suspension on there to have better adjustability of kinematics and how the whole car behaves.
5 links, so because we got 5 different components.
Exactly.
That
we got
together.
2 top links here. We got the bottom links, which take over the main force. That is mainly to guide the wheel in the right direction. And we got the 5th link, which is the toe link, which defines, first of all, how much you steer and how much you move that whole thing around.
I believe I heard about the 5-link configuration for the first time when the W201 was introduced. I mean, of course, I wasn't there for that.
Yeah,
that was in 1982, but...
Exactly. Yeah, the 5-link configuration is more or less the queen of suspensions. That was, as you rightly said, introduced with the 201 on the rear axle, and therefore taken over to all the bigger Mercedes cars, the E-Class, the S-Class, and is more or less the standard for the best configuration you can have.
Was it a big challenge or is it a challenge to transfer this configuration from the rear axle to the front axle?
Oh yeah, actually that was a big challenge because as you see, they are all bent in all sorts of ways. There's not a lot of package within the wheel, and it is moving as well. On the rear axle, you always got it in one line. So it is actually quite a challenge to get the kinematics right, to get the package right, to have a stiff configuration. That is quite a challenge.
Now, how do you achieve this is a very, like we said, a very motorsporty oriented car. How do you achieve a very broad range between comfort and sportiness that we have in our cars?
Well, we have our targets which we want to achieve, like for example toe change and so on, and obviously it's always, as you said, we need to move things around and get the best fit for our cars. All our configurations are differently in all our cars, and they all differ from the standard Mercedes. What we do is, like I said, we look at the positioning of the wheel over deflection. That's what we do by moving these points forward, backwards, up and down. These characteristics are very sensitive to moving them around. For example, the toe link, if you move it up 1 millimeter, that actually is feelable.
Whoa, okay.
So it is about a lot of precisement as well for getting it to the customer in the production car.
So this is completely bespoke for every car. The whole geometrical arrangement is bespoke, and
Yes.
important to note, it is specific on every AMG car as well.
Absolutely.
Compared to the Mercedes.
Absolutely. And
That is-
even like
wow.
in between the C-Class, for example, the C43 got a different configuration, different bushing settings than the C63.
That's, I think, something that many people overlook, that
Yes.
a lot of work goes into this part of the car, not just
Yeah.
the engine, when there is an AMG badge on the car.
Absolutely, absolutely. I was talking about the second thing which we actually take care of. It's how the whole forces get transformed to the body. So therefore we make sure it gets in the right parts. And the other thing that more or less defines how much the car is rolling, how much it's pitching under braking or pitching under acceleration. So we move them around, get the best fit, get the right forces into parts to later on introduce defined deformations in our bushings and in the parts to get some additional elastokinematics, toe angles, camber angles.
So how long does it take you guys to come up with a configuration like that for a car?
Oh well, that's quite a task. So normally it takes us between 3 and 4 months, I would say, to get it all together, get the right positions, make them work with the package as well. As you see, there's not a lot of space. We got the brakes in there, we got the steering there, we got the side shafts in there. So it's actually quite a tight package in there. And to get it all right in there, we need to closely work together with our designers and make sure it's all working together. And after we fixed all the connecting points, we are working on the parts and make sure they have the right stiffness. But I think Sebastian's going to tell you a bit more about that later on.
Cool, cool. Sounds awesome. Very nice. So, I mean, back in the G episode, we were at the Green Hell, of
Yes.
course, taking a closer look at
Yes.
how these things get tested on the racetrack. But everything we're talking about is happening in advance or in close correlation with those
Yes,
colleagues at the racetrack,
absolutely,
right?
Absolutely. We're working constantly together. So you met Marcus, you met Tom working on the elastokinematics. So we prepare the settings. They have to test, or they're going to test. They give us feedback from the test track. And it's always, as you mentioned earlier, quite a task to get all the different characteristics together. Yeah. So it's quite a task. So we have like 200-300 characteristics we have follow, different curves, and to get the best fit for a car, that's quite a task.
How do you work with these characteristics? Do you put them in some sort of mathematical models that you calculate, or do you put it just in the simulator that we're going to be taking a look at later on?
Yeah. Well, actually, we start with a basic kinematics model and just make it more scientific later on. We have a MBS model, so multi-body simulation it's called. So all these different parts are replaced by a model on its own, and that gives us the information how much they're moving, how much they're deforming the parts. When we have this characteristic data, obviously we got some experience where we want to be and where we think it's best. Then we have a whole vehicle dynamic simulation where the car is driven around by a synthetic controller. And then if we're happy with that, we take it to the simulator, because that's the perfect tool for us. We can get the test drivers in there, which are driving the car later on. We can drive it ourselves and we can give it to the management. Just form a target where we want to be later on in the ready car or in the finished car, and just have a whole flow of just like working together as a team.
Wow. We talked a little bit about elastokinematics. You
Yes.
mentioned that we're going to be taking a closer look at that with Sebastian.
Yeah, exactly. Sebastian is over there waiting for us, and he's got something prepared.
Let's go and meet him. Oh, that track really is a roller coaster.
So, Quittelbacher Höhe, braking, exactly, yep.
crazy.
Oh, hi guys.
Hi, Sebastian.
Hello there.
Hi guys. Hi
Hey
Felix.
there, how's it going?
Waiting for you. Very good, thanks. And you?
Very well indeed.
I can tell you something about elastic kinematics. So let's go. I have something prepared for you.
Awesome, okay.
So when we talk about kinematics, we mainly focus on the axle as how it moves upwards and downwards, and we regard it mostly as all the parts are stiff, but it doesn't happen in reality. All the parts are deforming, and we have in the suspension these rubber bushings that we use to decouple all the harshness that comes from the street, from the road, through the wheel, through the suspension to the chassis. And we have everything modeled here in our multi-body system.
So behind this little rubber part, there's actually a mathematical model.
Yeah, exactly. And there's also mathematical models from all these parts. These are finite element parts that we place inside, so we can see how everything deforms when we have, for example, here a lateral load. Don't worry, these deformations are amplified, so we can see them. We make pretty stiff here axles.
Okay, so it doesn't move that much in the actual car.
It helps to see, because we use such images to study what's really going on. We do really take a look at plots or graphs, but sometimes it's very helpful to see it in an animation, how it's everything behaving.
So this, for example, this movement right here would occur if I drove through a corner and I'd have a sort of a force going through the tire from me being able to go through the corner very fast, and then we'd see this deflection here.
Exactly. And what you can see here very good is we have here a lateral force that's coming from the cornering force on the tire, and you see that the camber angle is being reduced through this force, and that's what we are trying to reduce at a minimum. Because in that case we are losing grip. On the kinematic side, you try to gain camber when the wheels goes up, and that's what you try to do when you define your kinematics goals. And then you go to the street, and because of all these compliances, you are losing camber again. And we study what do we need to do, where do we have to stiffen up in order to reduce this camber angle, and also the toe behavior. And here is how do we take a look at it thoroughly. When we run these simulations, we take a look at comfort. We take a look at what happens when we have forces going forth and backwards. So the drive forces and the braking forces. And here we see what happens when we have lateral forces. So if we start here on the comfort side, we are trying to see that in this direction we have enough movement of the axle in the longitudinal direction, because when you hit something on the road, it will deflect the tire and the suspension in that direction, and it feels more comfortable. If you are very stiff here, then all the hardness will come through the chassis. Then we take a look at what happens with the toe angle, the direction of the wheel, when we have driving forces and braking forces. This is very important. We are talking about here of very small deviations in angle. We are talking about tenth of degrees, and these are very, very important because the tire is very sensitive to that, and professional drivers feel everything. Every tenth is felt. These changes in direction can upset the car or make it more stable. And that's what we try to tune up here.
The color always indicates the level of stiffness that you have in the part.
The color schema is the level of stiffness that we have in every bushing, and every straight that you see here, it's one of the 5 links that we have.
Okay.
So we know that when we touch this link from a very stiff to very soft, we are making a change in this direction, and we change that much when we brake and that much when we have a driving force.
Okay.
And it's exactly the same here. So this is, for example, the spring link. You see that it has a lot of influence. And what is very important, and it's very related to the kinematics, is that the directions of all these straights come from the kinematic. The kinematic itself defines in which direction or which link is working under which forces and what is changing. And the most important part for us is here grip. We are trying to reduce this camber loss. So in that case, you are seeing that the baseline variant that we are taking a look at is here. We look at camber angle and toe changes. And for example, you can see here, this is the camber link, and it's the part that's most responsible for the camber change.
Because the axis goes in that direction
exactly
along.
in that direction.
Okay.
Here, for example, we have the spring link, and here the toe link, and you see the toe link works mostly in the toe direction.
I think I get the hang of it.
And that's very, very interesting because when the driver comes and gives us feedback about how the car is behaving, he tells us where we are losing too much camber maybe. We take a look which of the components we can tune in and which influence does it have in all other characteristics of the axis.
But you also have to
here and here.
You also have to translate the feedback that the driver gives you into the model first, because I can imagine that the driver probably can tell you, well, in terms of this diagram what has to change about the handling of the car.
You have to try to interpret what's going on. Sometimes we can make measurements on the car and we see what happens, and then we have to translate it here. And what's very, very helpful is that we now have the driving simulator, so we can make changes here, put the driver in there and tell them, okay, is that what we are looking for?
Okay.
And you get immediately feedback about it.
So that makes me very, very curious about that driving simulator.
Would you like to see it?
Of course I would.
Come with me. To the control room.
Wow.
We are meeting here again, and he will explain you everything what's going on in here.
What is all that stuff?
What you see here is basically the head of our simulator, where we can control everything. So it starts from building models from different sources together and attaching them to our self-developed, for example, engine models or so on. Then we can take everything, compile it onto a special real-time machine for that, where this model then will run in a real-time environment. So that we can make sure that every time step takes exactly as long as a real-time. We have a couple of PCs here where we can watch everything which goes on. So we have the real-time machine here where we can check everything which goes in and out of the car. So like for ECUs and driver inputs and so on. We can even see all the settings he adjusted on steering wheel, for example, or drive modes and so on.
Yeah, I recognize those.
And then for sure we can watch our driver, what's happening, and if he's feeling fine or if there is any issue. And there we have our real-time telemetry, so we can have even more channels to check. So while we are driving, we can, for example, look at tire temperatures or everything, basically.
I gotta say though, it's pretty dark in there. I can only kind of see what's going on. I gotta take a closer look at this. Wow, it's basically just a giant movie theater with a car in it. That is impressive.
Well, the question is if you dare to champion.
Can I?
Could you like to give it a try?
Of course I would.
Let's go for it.
Awesome.
We have the VI Crate 250 here, 5 on 5 meters of travel potential. That steel plate, it's actually 2 parts to fix together. Each part weighs about 14.5 tons.
14.5 tons?
Yes, so it was quite a task to get them in here. In these black boxes, there are magnets actually in there pulling it down. And then we got air pressure pushing it up again. So we got a very precise, even gap. And it's pretty much zero friction. So without these actuators, you could actually push it around.
Wow.
But that's not everything. We got this laterally 1.2 G, but we got these 6 actuators, this hexapod, which actually gives us the possibility to move up and down, to pitch, to roll, and there we can add another 3.5 G acceleration, and that up to a very high frequency of 25-30 hertz. So it's actually moving quite a lot, that thing.
That is really impressive.
Yeah.
How much does one of those things cost? Like the whole setup?
Well, can't you tell the exact numbers, but it's around 4 million.
Okay, yeah, definitely too much for my budget. But
yes.
I gotta say, I mean, this really makes everybody who's passionate about gaming very jealous.
So if you got a lot of money, that's the simulator to go for.
Very serious business.
On top,
Crazy.
we have a cabin. That is our X1 bug. So that's what we use for developing the X1 with all the ECUs in there. But we can actually use it for all the cars we are developing. So we could actually give you the physics of a G model. We experienced that already, or a GT, or everything. So that we are not limited there. It's just about the interior feel.
I gotta say, nervousness is rising.
Yeah, so you want to have a go? I think you learned how to drive in the G-Class. You've been on the Nordschleife with Markus. So have a go. And normally you get a challenge as well.
I do?
So have you ever heard about motion sickness? Some people tend, the first few times they are in the simulator, because we are so close to reality, so your body thinks you're in the real car, but not everything is quite real. So some people get sick after a while. So your task is go around the Nordschleife, do a lap, and don't fill up that bag.
I'll try to not fill it up but not by missing it, but by actually keeping everything inside me that is in there. Thank you very much. I appreciate that, taking care of me like that. But I hope I'll not ruin your precious machine.
You're right. It's going to be fun.
Over the headphones, which are over there, and there we can you can speak to me in the control room, and then you can put on your seatbelts and you're ready to go.
Awesome, it's go time then. I hope I haven't promised too much. I'd say let's go for it. What can go wrong, right? I thought I could hold it. Guys must be thinking I'm driving like a madman, but this is actually a lot harder than it looks. So I'm trying to channel my inner Markus Hofbauer and try to remember what he told me about all these different sections.
Now we go for Hatzenbach section. This is Quiddelbach, Flugplatz and Schwedenkreuz. Steep uphill section. This was the famous Brünnchen. And now we go to Pflanzgarten 1 and 2.
But it's definitely very different when you're sitting in this thing and trying to remember where all the different braking points and turning points are. Getting a bit sketchy under braking here. Really not that easy, I gotta say. But it is a whole lot of fun. And it actually requires quite a bit of guts to go through the corners, because you know what happens when it all goes wrong.
depending where you go off, you can still get quite a shake. So the platform is capable of giving you a 3.5 point.
That is pretty rough. Crazy how precise everything feels. Like, car does exactly what I want it to do. Oh, now I go for the bumpy ride through the carousel. That was fun. I think I need a little break from this because you're working up quite a sweat in this box here.
Yeah.
Not too bad. I want to press pause.
Yes, please.
Wow. There really is no dignified way of getting out of that thing. Wow. What an experience that is.
Yeah, I hope you enjoyed it.
I did enjoy it. Absolutely crazy machine.
Yeah.
Unbelievable. Unbelievable what that thing can do. Wow. Wow.
Yeah.
I'm lost for words and my knees are quite shaky, I gotta admit.
You understand that we can actually use it to set up kinematics and to work on that. Obviously it takes a while to get used to and to be there, but you did really good.
Oh, thank you. I tried to go slow and steady, but also at slow speeds you can feel very exactly what the car is doing and when the tail is going to step out and how everything feels and moves, and it's really quite impressive, I gotta say. Thank you so much for having us here.
Thank you for being here.
This is a top exclusive experience and I really appreciate that. Thank you so much for letting me take it for a spin and explaining everything.
Sure, hope you had fun.
That was really cool. Definitely learned a lot today again. Yeah. So there you have it, folks. Kinematics, definitely a very complex topic, very technical topic. We tried to break it down as easily as possible to make it digestible. A very interesting topic though, to understand how our cars handle and why they handle the way they do. And driving this thing, that was just another life-changing experience, I gotta say. I'm still shaking and sweating. So if you guys liked what you've seen at home, definitely drop us a like, subscribe to the channel, leave us a comment what you would like us to shoot next. And most importantly, this one stayed empty today. I'll see you guys in the next one. Bye-bye.